see refrigeration and air conditioning so many ways, and refrigeration is nothing but it is defined as the process of providing and maintaining a set temperature well below that of surrounding atmosphere. Normally we have systems and surroundings. If any have surroundings or system may be a low temperature or high temperature, the temperature may be transferred from higher temperature to lower temperature. Already we know that. So in the refrigeration process, the temperature, we like in our home we have a refrigerator. We store foods, milk, anything. The heat extract from the stored materials, heat extract from the heat and convert to the surroundings. That is a refrigeration. Refrigerators and heat pumps. If the main purpose of the machine is to cool some object, I already said that we cool the place or an object, the machine is named as refrigerator. The refrigerator is applicable for industries, shipping, marine industries. Nowadays, fishing industries also use these refrigerators and bottle coolers. These are the refrigerators. The main purpose of the machine is to heat a medium warmer than the surroundings. The machine is termed as a heat pump. If we have in a warm space, the heat pump extract the heat to the warm space. Okay, we need a input to the work input to the motor heat pump. Then it extract from the heat from the systems or surroundings and transfer to the another place. So the room kept to be cool or cold. It's also similar to the refrigerator. A cold space to be prepared by a refrigerator. We give some power input and take a heat from the rooms or objects and extract the heat to the surroundings. This is also difference between the refrigerator and the heat pump. Terminologies of the refrigeration. Refrigerating effect. It is the most one thing we needed. It is defined as the quantity of heat extract from a cold body or a space to be cooled in a given time. We need we take AC. Okay, we put we set a temperature 18 degree to 24 degrees Celsius. It's a correct temperature for a human body. It's take time 1 hour time to be cool the room. Okay, this is called a refrigerating effect. The heat extracted from the cold space divided by time taken. Next one, a specific heat of water and ice. It is the quantity of heat required to rise or lower the temperature of 1 kilogram of water or ice through 1 Kelvin or in 1 second. How much amount we heat the ice or water to be increase the 1 degree of Celsius? How much amount of heat provided or removed from this object, that is called specific heat. Okay, we provide heat or remove heat from this object, that is called as specific heat. If the object is water and ice, that it is called as specific heat of water and ice. Capacity of refrigeration unit. The capacity of refrigeration unit is in British thermal. We calculated as a British thermal unit. The British thermal unit is 1 ton of refrigeration is equal to 12,000 BTU. That means British thermal unit. BTU represents the British thermal unit. How much we consider a single room. The 1 ton of water to be converted into ice at duration of 24 hours at 0 degrees Celsius. That is called 1 ton of refrigeration. The latent heat of ice is equal to 336 kilojoule per kilogram. Per kilogram of ice we provide 336 kilojoule to convert the water into ice. That is called latent heat of ice. This is the formula. The 1 ton of refrigeration equal to 336 into 1000 kilojoule per 24 hours. The hours is converted into minute. So divided by 24 into 60 seconds. If we needed to kilojoule per minute to 33.33 kilojoule per minute, then equal to 3.8889 kilojoule per second. This is the terminology of a refrigeration coefficient of performance. If any systems we calculate the performance, how it works, how it if we give an input and we get an output. So how the output we get, that is called as a coefficient of performance. If we consider an evaporator, the heat is extracted from your room. We put the input and how much amount of heat is extract from a object or a material from the evaporator. That is the coefficient of performance of a performance. Then another formula is coefficient of performance is refrigerating effect to the work input. The refrigerating effect, we know that already how much amount of time to be taken to extract from the heat in a room or an object. That is called a COP or refrigerating effect. That is we placed here. The COP is always greater than 1 and known as the theoretical coefficient of performance. The COP is always greater than 1. That is called theoretical coefficient of performance. In olden days, the refrigerant is a liquid that is vaporized in a low temperature and also extract the heat easily from the surroundings or systems and objects. That is called a refrigerant. In olden days, we use salt is the most preferable refrigerant in our daily life. Nowadays, we use an air, ammonia, carbon dioxide, sulfur dioxide, freon, methyl chloride, methylene chloride. That's also used as a refrigerant. These refrigerants are easily take the temperature from the systems objects and easily convert to liquid stage to vapor stage. The required amount of heat is to be low to vaporize or boil. The boiling point of refrigerant is low. We consider normally the water boiling point is 100 degrees Celsius, but the ammonia have it at 40 degrees Celsius to vapor or to change its phase. Okay, this is so we take these refrigerants. The classification of refrigerant, it's classified as primary refrigerants and secondary refrigerants. The primary refrigerants, it is a working medium which is used for cooling the substance by absorption of latent heat. Latent heat is nothing but we know that sensible heat and latent heat. Sensible heat means if you are boiling a water to consider, we take a burner and above that the water is boiling that. From normally a water temperature is 30 degrees Celsius. If we boiling the water, it's rise continuously, seriously, 32 degrees Celsius to up to 100 degrees Celsius. The only temperature will be rise, but its phase is constant, never change to water to vapor. It's want to be constant. The phase is never change that. After when it's attain a boiling point, it will change its phase. Okay. Sensible heat means the only temperature will change, never change its phase. That is called sensible heat. Latent heat means it changes phase, temperature should be constant. When it attains 100 degrees Celsius, the water should be change its phase, liquid to vapor stage. Okay, we provide more amount of heat. The temperature, the 100 degrees Celsius, it should be constant, but the vapor should be superheated, heated and superheated stage. At the last drop of water should be contain 100 degrees Celsius. That is called latent heat. Okay. The secondary, primary refrigerant. The primary refrigerants are example to that ammonia, NH3, carbon dioxide, sulfur dioxide, freon, 12, etc. And our secondary refrigerant. The secondary refrigerant is a substance already cooled by primary refrigerant and then applied for cooling purpose. It is a secondary refrigerant is already cooled by primary refrigerant, ammonia, carbon dioxide, sulfur dioxide, freon. It is preferred. The primary refrigerant is initially cooled the secondary refrigerants, and the secondary refrigerant is combined to the primary refrigerant to extract the heat from the objects, rooms, and surroundings, anything. Okay, it is ice, solid carbon dioxide. These are the secondary refrigerants. Cool the substance by absorption of the air sensible heat. We know that sensibility, what is that, and sensibility means nothing but it's here only we provide heat. Only temperature will rise, never change its phase. Okay. Types of refrigerator, ice refrigerator. Ice is kept in the cabinet of refrigerator, and this acts as the refrigerating means. It's only contain ice only. In ice companies, ice bars, the ice bars are kept in these ice refrigerators only, because in olden days the thermocol is used as a ice refrigerators to contain the ice. Okay, and air refrigerator, air is used as working agent in these types of refrigeration. Bell-Coleman cycle in a cryogenic refrigeration cycle. At this place we use Bell-Coleman cycle. Vapor refrigerators. Vapor refrigerator, the working agents employed in this type of refrigerators are ammonia, CO2, sulfur dioxide, freons, etc. These are vapor refrigerators. It is easily vapor from liquid to vapor stages. Already we told that the ammonia boiling point is 40 degrees Celsius. Normally we have kept water in a 30 degrees Celsius, nearly to that. So ammonia is used as a refrigerant. It's easily available to everywhere. So we prefer ammonia. Nowadays our refrigerator use a chlorofluorocarbon CFL2 thing. Application of refrigerations. It's mostly used in a chemical industry to separating and liquefying the gases from in a separate container. Okay, and also it is used in a manufacturing the ice from the water, and it's preserved and stored in that. Okay, from the preservation of perishable food items in cold storage. For example, we have the fishermen go to sea and fishing. Then it is stored in a preservations, because the preserved for a long time then it's a cooling water. The application of it is cooling water for controlling humidity of air, manufacture and heat treatment of steels. The important one thing is the heat treatment of steels industries to be used a refrigeration system, because the heat treatment is to provide more amount of heat, liberating the more amount of heat in these industries. So due to that we have a heat cramps to be occur of the human, so they are suffered from that. So the heat treatment of steel industries are providing refrigerations for sealing the oil to remove wax in oil refineries. For in a cold spaces, the oil to be changed to its phase, liquid to solid. So the wax of oils refineries are used to remove the sealing of the oil. Okay, then for the preservation of tablets and medicine in pharmaceutical industries, the tablet industries and the medicines factories are used a refrigerator to protect the tablets and medicines in these industries. Okay, then the next the medical application is blood to preserve the blood tissue from one, it's take one place to another place. So we need that. The blood tissues are to preserve, secure and preserve it. The next one is for comfort air conditioning. The hospitals, states, etc., malls. Nowadays the air conditioning is here another type of refrigerations. Okay, the refrigerator is used to do the heat except from the object or anything. It's instead of that we extract the heat from a room. That is called as air conditioning. Properties of refrigerations. A good refrigerant should have a high latent heat of vaporization. So it's need a low amount of boiling point to vaporize the liquid to vapor stage. That is a good refrigerant. We need that. Then again the second one is it should have low boiling and low freezing point. Its freezing point is to be low because it easily vapor to solid. It may be changed easily, changed into solid. So we need that low freezing point. It may be negative also. It should be non-toxic and should not corrosiveness, because if it is corrosiveness, the food easily corroded and it is a toxic things to be. If it is we taken, it make we be suffered by a lot of sick. Okay. The fourth point is it should be non-flammable and non-explosive. If we take again any car, vehicles, etc., explosive, some instruments or some systems have explosive things, but the chemical are mostly explosive things. But the refrigerants we take, that should be non-explosive things. Okay, if we how we say, because we store in a refrigerator we use in medical industry. If it is explosive, we need to take dramatic changes and dramatic explosive. It will suffer the sick persons. Okay. The next one, it should have high thermal conductivity. The refrigerant should be high thermal. It is the most one needed for a properties of a refrigeration. High thermal conductivity. If it is have a high thermal conductivity, it will change the heat from one place to another place with ease. Okay, and it should be, the another point is it should be easy to handle. Some chemicals are to suffer to make injuries or itching. So it should be easy to handle. Then another point is it should have low specific volume of vapor. And another last point is it should have high coefficient of performance. If performance is compared to other refrigerants, it should be high. This is the vapor compression refrigeration system. Normally, a refrigeration system to be classified as a vapor compression refrigeration system. That means VCRS system, and that another one is VARS system. That it is called as vapor absorption refrigeration system. In this device, in this system, major four components are available here. One is evaporator, and another one is compressor, and another one is condenser. The last one is expansion valve. Okay. Initially, we store a refrigerant in a reservoir. Then it passes through the evaporator. The evaporator contains a coil. It's a copper coil in a limited space. At its diameter is minimum. It's an allowable one. The refrigerant passes through the copper coil. Okay, the heat is extracted. We have that means the aluminum coil. If we consider a domestic refrigerator, the copper coil is kept in this inside of refrigerator. Okay, we stored foods, milk, eggs. So many things kept in this refrigerator. These objects temperatures are extracted from this by convection. We already know that mode of heat transfer. It's occur from conduction, convection, and radiation. Conduction, that means nothing but it's heat transfer from solid to solid. Convection means solid to liquid or liquid to solid. Then radiation. The radiation means it's transfer the heat without any medium. Okay, radiations. In this evaporator, the heat is extracted from the object. The ammonia is, and the ammonia or where other refrigerants, it is stored in a reservoir. It passes through the copper coil. The heat extracted from the system or rooms. Rooms are other objects, other things. It heat extract from that, and the flowing refrigerant is change its phase because its boiling point is very low compared to water. Okay, it change its phase from liquid to vapor because its boiling point is too low. Okay, then it passes through the compressor. It passes through the compressor. Okay, the evaporator is so many evaporators are now available in this refrigerant system, DX evaporator, fluid evaporator, dry evaporator also available here. It's any one of evaporators is that we consider the phase changed where the refrigerant is passes to compressor. The compressor compress the vapor. Okay. Before that, the refrigerant is high temperature vapor before entering to the compressor. Okay, before entering the compressor, the vapor is low pressure and high temperature. Okay, after the compression process, the outlet of the vapor gas is increased its pressure, because the compressor compress the vapor and also increase the pressure of the refrigerant. Okay, then it should be changed high pressure, high temperature vapor. Then it moves to the condenser. The compressor is a different type of compressor are available now. Reciprocating compressor, open type compressor, hermetically sealed compressor, semi-hermetically sealed compressor, and rotary compressor. Rotary compressor, it's maybe further classified into 3 types: screw compressor, rotary vane, rotary blade type, and further it's further one type is centrifugal compressor. These are the types of compressor now we used in so many places, so many industries, but the open type compressor is mostly preferred in industries. Okay. Then the high pressure, the high temperature vapor further is moved to the condenser. In a condenser, the heat is extracted from the copper coil, and it is transferred to the surroundings. Already we know that in a domestic refrigerator we see back to back refrigerator back we see coil, aluminum steel coil. That is one type of condenser. It is cooled by the air cooled condenser, because the air is cooled to the condenser coil. The heat is extracted by the convection process and it is moved to the surroundings. So this process is continuously run again and again. Okay. Due to that, the room or an object is extract the heat and change to phase change vapor, and it moves to condenser. In this condenser, air cooled condenser. If we forced convection, or it may be a normal convection to be an occur. If it may be forced convection, we provide additional set of fan, like an air conditioner output unit. We provide fan, 3-blade fan. The fan is extract the heat from a coil by a convection, and it is extract to the or transfer to the surrounding. So the passing the vapor is changed into liquid, because its heat is taken. So it's the refrigerant is phase change from vapor to liquid. Then it passes through the capillary tube. Okay, if it is the condenser is classified as a air cooled condenser, water cooled condenser. If it is a air cooled condenser, then it is further classified into forced convection or free convection. Okay, then if it is a water cooled condenser, the water cooled condenser is a large type of refrigeration system or macro size of refrigeration system, air conditioning system, like in a theater, mall, shopping malls, wherever, hospital, wherever it is. It should be have a water cooled condenser. The water cooled condenser have a cooling tower. It's the cooling tower is placed in a height, it's increase the height level. It's placed in a topmost portion of a building. Okay, the cooling tower extracts the heat from the cooling water, and it is passed through the air. Okay, then it's further moved to the capillary tube. The capillary tube is an expansion device. The expansion device further classified into thermostatic expansion valve, automatic expansion valve. The high in a condenser, the temperature of a vapor is reduced. So the output of the condenser is high pressured but low temperature liquid. Okay, then it's further moved to the capillary tube. In a capillary tube, the expansion process occurs. So the temperature of the refrigerant is already reduced. In this capillary tube, the pressure is reduced by an expansion. When the area is sudden increase, the pressure also decrease. This is the concept in a expansion device. So the vapor is fully converted into liquid stage. Then it's moved to the evaporator. Then it extracts the heat from the systems or object, any room or anywhere. Okay. Then it's the process continually run again and run again. Okay. This is the vapor compression refrigeration system. This process is accounted into the refrigerator, air conditioner. Okay. This is the VCR systems. Okay. Then move to that next slide. These also already say that. Okay. This is the where is the evaporator? This is the evaporator. Evaporator extract the heats and it's moved to the compressor. Then the monitor, the pointer, the low set pressure gauge. It shows the low pressure value of the refrigerant. Okay. Then it's moved to the compressor. The compressor compresses the refrigerant, vapor refrigerant. So in this stage, the high pressure vapor is converted. It shows the pointer. Okay, the gauge. Then it's moved to the high pressure side and it's moved to the receiver condenser. In a condenser, maybe an air cooled or water cooled condenser. Then it further moved to receiver. After that, expansion valve, then evaporator. This process again and again running. Okay. Due to that, we get the cold space or preserved food material. This is the entropy TS diagram of a vapor VCRS system. Okay. In a evaporator, that means QL, cold refrigerator space. First of all, latent QL. Okay, the heat is provided. Then it's provided to the evaporator. Heat is provided means that means extracted from it's automatically extract the heat from these systems. Then it's moved to the compressor. The compressor is a piston type compressor. That means a reciprocating compressor. We give an work input to the compressor. So due to that, it's compress the refrigerant to the pressure, increase pressure rise. Then it's moved to the condenser. In a condenser, the heat is rejected. Then it is fall its temperature, it change its phase. Then it move to expansion valve. In expansion valve, the pressure is reduced. Then it's moved to the evaporator in a liquid phase. Okay. This is TS diagram for a VCR system. Okay. It's a detailed elaborated that vapor compressor refrigeration system constructions. The system consists of a compressor, condenser, a receiver tank, and an expansion valve and an evaporator. Compressor. A reciprocating compressor generally used. Already we say that reciprocating compressor, open type compressor, hermetically sealed compressor, semi-hermetically sealed compressor. If you have a hermetically sealed compressor, the hosing is fully closed. So one time, if it is a fault and fault season occur, we throw it away and we put place on a new compressor. Okay, no maintenance is placed in that hermetically sealed compressor. If it is a hermetically sealed compressor, a small amount of vent is placed here, provided that we only change the oil in a particular time. Okay, that is that. Large industries use the open type reciprocating compressor. Okay, for very big plants, centrifugal compressor directly coupled with high speed rotating engines, gas turbines used. The gas turbines provides electric power provided by the alternator and it is coupled with a compressor. So we have provide more amount of energy. So the compressor should be run. Okay. Yeah, it may be a turbo shaft engine. The combustion chamber, the fuel and air fuel mixture, then hit into the turbine by a momentum principle. Then due to the momentum principle, the turbine will be rotate. The turbine, if a turbine rotate, the shaft is coupled to the compressor, so the compressor will rotate. So we need a power from the compressor. If it is a rotating compressor, okay. For compressor, directly coupled with high speed rotating engines, gas turbine used. These are the gas turbine engines. That means a centrifugal compressor. It's not an axial flow compressor, it is a centrifugal compressor. Okay, the next one is condenser. It is a coil of tubes made up of copper. Because the thermal conductivity of copper is high. Okay, it's high. Thermal conductivity copper have a high thermal conductivity, so it should be used. But its rate is an amount. It is expensive too also. Then it's a receiver tank. It is the reservoir of a liquid of a reservoir. Or even particular time we store a refrigerant in a receiver tank. Okay, if it is disappear, the ice formation will appear in this copper coil in everywhere. So we see that in a naked eye. Okay, then expansion valve. This is a throttle valve. High pressure refrigerant is made to flow at a controlled rate through this valve. How much amount of refrigerant is flow through this pipe or coil? That is decided by an expansion valve. So the expansion valve should be needed. That is already I say that the expansion valve should be classified as a capillary tube. It's range from 0.5 mm to 5 mm. Its diameter, I think. Okay, its length to 15 mm or 5 meter length to length. It depends upon the application. We provide the capillary tube. Okay. Then another type of expansion valve is thermostatic expansion valve and automatic expansion valve. Then if it is a thermostatic expansion valve, the sensible bulb is attached to the evaporator input. Okay, the evaporator output. So it sends how much amount of heat we needed. That sensible from the sensible bulb. Due to the depends upon the heat, the expansion valve will be open. How much amount of refrigerant it's needed to the evaporator. Okay, evaporator, it is the actual cooler and kept in the space to be cooled. The evaporator is a coil of tubes made up of copper. It's also made up of copper similar to the condenser, because it also have a high thermal conductivity. He extract the heat from the system or surroundings. Okay. The working principle, I already told that the low pressure refrigerant vapor coming out of the evaporator flows into the compressor. Initially, the low pressure refrigerant vapor comes from the evaporator. Okay, then it flows into the compressor. The second point, the compressor is driven by a prime mover. The prime mover means if it is a gas turbine engine, the gas turbine rotate the compressor. If it is a centrifugal compressor, the gas turbine rotate the compressor. Okay, if it is a reciprocating compressor, we need a prime mover to rotate the compressor or to move the reciprocating motion. To move the reciprocating motion, we need provide a power from the prime mover. Prime mover is an electric motor. It's nothing but in this compressor, the refrigerant vapor is compressed. Okay, then the high pressure refrigerant vapor from the compressor is then passed through the condenser. Next one, the refrigerant gives out the heat is had taken in the evaporator. The sixth point, the heat you saw the slide. Already I told that this is the working principle because I shown the figure. Okay, the heat equal of work done on it and the compressor. The next one, the heat is carried by a condenser medium, which may be air or water. I already told that air cooled condenser or water cooled condenser. It's dependent on the situations or a large buildings or large scale of industries or large rooms. It's dependent upon if we extract the heat is large amount, then we provide water cooled condenser. Okay, the air condenser only available or it's only affordable for a small refrigerator, small type of bottle cooler, small type of air conditioner only. Okay, it's not applicable for large space rooms or industries. The next one, the high pressure liquid refrigerant then enters the expansion valve. I already told you, in a condenser the vapor is changed into liquid sink because the heat is transferred from condenser to surroundings by a convection process. The ninth point, these valves allow the high pressure liquid refrigerant to flow at a controlled rate into the evaporator. High pressure liquid refrigerant to flow a controlled rate in the evaporator. So then the 10th point, while passing through this valve, the liquid partially evaporates. Partially evaporates, fully not, it's not a fully evaporate, partially evaporates because its boiling point is very low. Like an ammonia is a 40 degrees Celsius is a boiling point compared to the water. Okay, the 11th point, most of the refrigerant is vaporized only in the evaporator at a low pressure. If it's a low pressure, because underline that, a low pressure. If a container have a low pressure, water also boiling at a low temperature. That's a phenomenon. Okay. Then next one, 12th point. In the evaporator, the liquid refrigerant absorbs its latent heat of vaporization from the material, which is to be cooled. I already told that this point. Then 13th point, thus the refrigerant effect is N. It is obtained. How much time to take the heat from the room or object? That is a refrigerator. We know that. Then 14th point, then the low pressure refrigerant enters the compressor and the cycle is repeated again and again. Our destination is to be attained. How much amount of heat is extracted and how much space is to be cooled. Okay. Then we further move to the vapor absorption refrigeration system. Vapor absorption refrigeration is vapor VAR system. It is similar to the VCR system, but one thing, in this system we have additional parts or additional components to drive the refrigeration system. Okay, so many systems are, instead of we use so many parts instead of compressor. In this system, compressor is not available because that we have so many components, generator, absorber, rectifier, analyzer, so and so. We pump, heat exchanger, we use that. Okay. In this system, the compression process of vapor compression cycle is eliminated. Instead of that, the following three processes are carried out. The water process are absorbing ammonia vapor into water. So this is an oxide ammonia refrigeration system by a vapor absorbing refrigeration system. Okay, absorbing ammonia vapor into water. Okay, in this case, the ammonia is used as a refrigerator and the water is used as a absorber. Okay, then pumping this solution to a high pressure cycle. This mixed solution or a style, maybe in a strong solution or a weak solution, depending upon the situations, this mixed solution is pumping into a high pressure cycle. Okay, then it's moved to producing ammonia vapor from ammonia solution by heating. If it is separated or isolated the ammonia vapor to heating, we provide the heat via a burner or solar heating or a coal heating, whether it may be anything. Okay, this is a water ammonia vapor absorption refrigeration system. Okay, first we show that figure in a evaporator. In a evaporator, your ultimate aim is to reduce in a evaporator or a container. Okay, stored container. In this case, we use a stored container in a brine water. Okay, the brine water temperature to be reduced. Should be reduced by this system. Okay, if the temperature of your brine water is 32 degrees Celsius, it should be reduced to the 18 degrees Celsius. Okay, for to consider that it's not accurate, we consider some light amount of that. Okay, first of all, the ammonia refrigerant is flow through the evaporated coil. In this case, the ammonia is, the heat is extracted from the coil. Then the heat is transferred to the refrigerant. So the ammonia boiling point is to be low, so change its phase. Liquid to vapor. The ammonia vapor is passes through the absorber. The absorber contains a water, cooling water. The cooling water is passed through a cooling coil. Okay, so the absorber is maintained at a low temperature compared to the evaporator. In a low temperature, the vapor is passed through the absorber. The water and the ammonia has highly affinity. It's bond each other very close. So the water is absorbed more amount of ammonia vapor. So it's changed into weak solution. It's strong solution. It's absorbed. So it is highly affinity. So it absorbs more amount of ammonia vapor and it passes through the pump. It's a strong solution. Okay, it passes to generated by a liquid pump. Okay, in between that heat exchanger, in between a generator and absorber, two components are placed here. One is heat exchanger and another one is pump. The pump is pump the strong solution to the generator through the heat exchanger. Okay, the heat is in the heat exchanger. The heat is transferred to the strong solution. Then it's moved to the topmost position of the analyzer. Okay, in this analyzer, the analyzer is topmost position of the generator. In a generator, the heating coil is provided to produce a heat, or if the heating coil is a heating oil, we pass through the steam or hot water, or if it is be used by a burner or solar panel heat, anything instead of that. Okay, in a generator, the water ammonia solution is heated. The boiling point of the ammonia is 40 degrees Celsius. In this heat, the ammonia is vaporized. Okay, the water is settled down on the below of the generator, bottom of the generator. Okay, the vapor is then passing to the cooling tower. If it is a small drop amount of ammonia vapor is escaped from the analyzer, it is removed by the rectifier. Okay, if some amount of water is escaped from the analyzer, it is rectified by the rectifier. Okay, because it have a cooling water by a cooling coil, the ammonia vapor is condensed. The water vapor is condensed. So the water vapor is condensed and it is again passes through the generator. Okay, in a generator, the strong solution is changed into weak solution, because when the ammonia and water vapor are mixed, then only it is called as strong solution. If now the ammonia is vapor into the pass to the rectifier. If only we have a water, so it is called weak solution, water. So it is called weak solution. The weak solution is passes through the heat exchanger, to the absorber. Okay, this process is run again and again. Okay, after the rectifier, in a rectifier, the cooling water is passes through by a coil in a rectifier, eliminating the water. The remaining ammonia is passes through the condenser. This is also a water. It have a water cooled condenser. In a water cooled condenser, the cooling water is passes through the coil. Then it's further into be condensed. The ammonia is condensed into from vapor to liquid stage, and it is passes through throttle or a expansion valve. Its pressure is to be reduced and it moves to evaporator. Then it extracts the heat from the brine. Then it goes to absorber, pump, generator, rectifying, eliminate the ammonia vapor, then it's moved to the condenser, then this process again and again run. The process should be again and again, our destination, our outcome will be reached. Then finally the temperature of the brine should be reduced. This is the VCRS system. Okay. Then vapor absorption refrigeration system construction. The vapor absorption system consists of a condenser, an expansion valve and an evaporator. They perform the same as I already told that vapor compression system. In addition to this system has an absorber, heat exchanger, an analyzer and rectifier instead of compressor. In this system, we don't show that compressor. Instead of that, we using absorber, a heat exchanger and an analyzer and a rectifier. Vapor absorption refrigeration system working principle. Okay, working principle: dry ammonia vapor at low pressure process into the absorber from the vapor evaporator. Okay, the next one, in the absorber the dry ammonia vapor is dissolved in cold water and strong solution of ammonia is formed. I already told that in an absorber, the absorber contains a cooling water from a coil to the cooling coil. I already told the water is having a high affinity to the ammonia, so it's absorb more ammonia. Then it's moved to the generator. Okay, the highly concentrated ammonia known as aqua ammonia is then pumped by a pump to generator through a heat exchanger. It's in heat exchanger. The strong ammonia solution is heated by the hot weak solution returning from the generator to the absorber. The heat source is to be a burner like solar wood, anything. The next one, in the generator, the warm solution is further heated by a steam coils, gas or electricity, and the ammonia vapor is driven out of solution. The boiling point of ammonia is less than that of water, hence the vapors leaving the generator and mainly of ammonia. The weak ammonia solution is the left in the generator is called weak aqua. This weak solution is returned to the absorber through the heat exchanger. 11th point is ammonia vapors leaving the generator may contain some water vapor. The water vapor is rectified by the rectifier. Okay, this vapor is allowed to the condenser and expansion valve. It may freeze, resulting in the choked flow. Analyzer and rectifiers are incorporated in the system before condenser. Then 14th point, the ammonia vapor from the generator passes through a series of trays in the analyzer and ammonia is separated from the water vapor. The separated water vapor returned to the generator, then the ammonia vapor passes through the rectifier. Okay, I already told that these processes are same thing. The rectifier resembles a condenser and water vapor still present in ammonia vapor condensers and the condensate is returned to analyzer. The virtually pure ammonia vapor then passes through the condenser. The latent heat of ammonia vapor is rejected to the cooling water, circulated through the condenser and the ammonia vapor is condensed to the liquid ammonia. Then the high pressure liquid ammonia is throttled by an expand valve or throttle valve. It may be an expansion cavity tube, thermostatic expansion valve or an automatic expansion valve, whatever it may be. Then it's reduced the high temperature of the liquid ammonia to a low value and liquid ammonia partly evaporates. Then this is leads to the evaporator. In the evaporator, the liquid fully vaporized. Okay. Then the latent heat of evaporation is obtained from the brine or other body which is cooled. The low pressure ammonia vapor leaving the evaporator again enters the absorber and the cycle is completed. Okay. The one cycle is completed. This cycle is run again and again, repeated. Okay. The application of refrigeration system. Preservation of food items like vegetables, milks and etc. The milk container also contain this type of VCR system. Preservation of medicines, preservation of fluid, tissues, etc. Preservation of cooling of cold drinks, other that mean a bottle cooler or bottle industries, beverage industries like that. Preservation of chemicals industries, cooling of water, industrial and comfort air conditioning. Processing of dairy products. Today, dairy products are a vital role in our daily life. So the VCR system also used in the dairy products. These are the comparison between that VCRS and VAR system. This system has more wear and tear and produces more noise. The VCR system produces more noise compared to VAR systems, and it contains a aqua pump. VAR system has a contain a aqua pump. Electric pump is needed to drive the system in a VCR system, but waste of exhaust steam may be used. No need of electric power in this VAR system. Electric power, no need for an VAR system, but the VCR system contains electric power to drive a compressor. Okay, the coefficient of performance is more compared to the VAR system. In a VCR system, okay, the COP is less in the VCR system. At the party load, performance is poor in this VCR system. VA system have a party load performance is not affected. Mechanical energy is supplied to compressor. So, if we place a compressor, we need definitely a mechanical energy drive from a compressor. Heat energy is useless because instead of we place the analyzer, generator, absorber. Okay, energy supplied is 1/4 to half to quarter of the refrigerating effect less. In a VAR system, energy supplied is about 1.5 times the refrigerating effect is more. The 7 point, the charging of the refrigerating system is easy in a VCR system, but in a VAR system, the charging of refrigerant is too difficult compared to VCR system. The preventive measure is needed silently, since liquid refrigerant accumulated in the cylinder may damage to the cylinder in a VCR system. But the liquid refrigerant has no bad effect on the system of VARS system. Okay, if this is a domestic refrigerator in our daily life, we use this so many times, morning to evening, full day, we see the domestic refrigerator in our daily life. Wherever it is, in hotels, malls, shopping, everywhere. Okay. This is the schematic diagram of a domestic refrigerator in our daily usages, where it is placed the evaporator, where it is placed in a condenser cabinet to compressor. The compressor, we shown that the back of the refrigerator, we see a black color solid material, that is a compressor. It's providing more noise. Domestic household refrigerator use vapor compression cycle, less energy, 90 watt to 600 watt, due to small and high efficiency motor and compressor. Then better insulation material, large guard surface area, better door seals. If it's a door is a leak, if you go unsealed, we have more power consumption. The seal is a very necessary one thing. It's a properly, okay, designed to maintain freezer section 80 degrees Celsius, refrigerant section 3 degrees Celsius. Insulation material fiber class. It's a thermal conductivity is 0.3032 Weber per meter degree Celsius. Then urethane foam, that's its thermal conductivity is 0.019 watt per meter degree Celsius. Wall thickness of foam for freezer section 90 to 48 mm. For free refrigeration section 70 to 40 mm. Works better up to the environment of 43 degrees Celsius. Ice maker 2 to 3 kg per day. Vapor absorption is more expensive and less efficient. Energy consumption can be minimized for practicing good measures. How we use the refrigerator? That's why we have a power consumption. Depends upon that. Open the refrigeration source few times possible. The refrigeration effect is to be taken more time. So we need a more power consumption. Cool the hot foods to room the temperature. Clean the condenser coil. Begin the refrigerator. Check the door gaskets for air leaks. Avoid unnecessary low temperature settings. Okay, we avoid that unnecessary settings. Avoid excessive ice buildup. If it's ice buildup, we remove and a certain time to buy appropriate things. Okay, use the power saver switch. Do not block the airflow passage from the condenser. Don't put the refrigerator close to the near to the wall. Some spaces we need, some spaces we provide to the condenser coil, because it is an air cooled condenser we provide it. Okay. Then air conditioning. Air conditioning is an application of refrigeration system. Air conditioning is nothing but when we feel comfort psychologically and physically, this temperature is be enough that it's a the human comfort. That is called an air conditioning. It's provide a pure air to that. Okay. Thank you. We see you in the next session.